For a project, I set out to find, is there more sand in the soils in the yard in the flower bed than in the soil in the garden? My hypothesis is that there will be less sand in the garden. My materials were 3 mason jars, water, a garden shovel, a ruler, safety goggles, which were sunglasses, 3 soil samples, and a variable hat. The variable was the soil from the garden was brought to the house especially for cleaning. And my conclusion was that the hypothesis is true. There is less sand in the garden than in the yard. There is less sand because the garden soil was prepared for cleaning.
Good job.
Very good job. Excellent. Elizabeth, that was very well done.
My name is Hannah, and I'm doing what happens in organisms. So, the first step I have to do is we have to cut one banana in half and put them in their own separate bag. Then label them and put yeast in one bag and observe them for 6 days. And
What were the materials that you used?
okay, the materials I used was yeast, 2 plastic bags, and 1 banana.
What was your hypothesis?
My hypothesis was that I thought the yeast banana would stay longer, but clearly I was wrong.
And what did you learn?
That I was wrong about the yeast. I thought the yeast would protect it from being decomposed.
Good job.
Good job, guys.
Measure humidity. My hypothesis was when it is humid, the hair gets shorter. When it's moist, the hair gets longer. My materials were a large jar lid, wooden block, cardboard and stiff paper, pencil, thread, ruler and sponge, tape, towel, thumbtack sink, and straight pin. My observations were it is a pattern first, it is 4 and 5.5. My data is day 1, it's 4 humid. Day 2, it's 5.5 humid. Day 3, it's 4 humid. Day 4, it's 5.5 humid. And day 5, it's 4 humid. My conclusion was I learned you can measure humidity and learn the meaning of hygrometer. My hypothesis was right. I can improve my hygrometer if my mom let me borrow some from here. For my project.
Good job.
Very good.
My name is Mia Chalmers, and my project was surviving in the cold. My question was, how do animals survive in the cold? My hypothesis was, how do animals survive in the cold? Is it because of their fur, or is it because of their hollow skin? My materials I used were 3 jars the same size, water, a thermometer, fur material, and a downwash jacket. My procedure was fill each jar the same level with very warm water. Measure the temperature of each. All 3 jars must be the same temperature. If not, pour a little water from each jar and stir. Keep on doing this until all the jars are the same temperature. My conclusion was once the procedure was complete, all jars had the same temperature every 10 minutes. When I took the temperature of each jar, all of the temperature changed. The uncovered jar lost the most heat. The jar covered with the fur material stayed the warmest. The best way to stay warm in the cold temperature is to be bundled up with warm material such as fur, fleece, or down. These materials keep you warm for cold temperatures.
Very good.
My question was, which magnet was stronger? My experiment was I had the hang paper clips on a paper clip.
But what was your hypothesis?
My hypothesis was a U-shaped magnet is stronger.
So you're looking at two different types of magnets?
A bar magnet and a U-shaped magnet.
Okay.
My materials use one bar magnet, one U-shaped magnet, 20 paper clips. My observation was the U-shaped magnet held 20 paper clips. The bar magnet held 20 paper clips, but started to slip. My conclusion was the U-shaped magnet was stronger.
So your hypothesis was correct. Very good.
What is the scientific reason the metal comes up toward the magnet? My hypothesis. I think we will not pick up the eraser, the pencil, the ruler, the plastic protector. My object was the screw, the plastic protector, a ruler, a magnet, an eraser, a pencil, and a paper clip. What can a magnet pick up? Magnets pick up and stick to many different things. They come in different shapes and sizes. They have different strengths depending on their size. They have a force called a magnetic force. If not stored properly, magnets could lose their magnetic force. The hypothesis was right. My observation, it picked up the paper clip, the screw, and that was it. Conclusion, it did not pick up what I said it would not pick up. And that's my project.
Very good job.
My name is Erica, and my project today is the Duke of Coop. My question is, how does salt affect a cucumber? My hypothesis is, I think the salt will make the cucumber change colors like a pickle. My materials are 2 cucumbers, 2 bowls, water, and 1 tablespoon of salt.
And your conclusion was what? Tell us again what your conclusion was.
I learned that salt makes the cucumber limp and wilted. When I held the cucumber without salt, it was hard and crisp. But when I held the cucumber with salt, it was limp in my hand. It took some time for the cucumber and salt water to change from crisp to limp. It was an instant change.
My question is, do plants really drink food coloring? The first day, it just looks like regular celery. The second day, maybe you start to turn red or blue. The third day, it looks like this. And some of the water is going up in the roots through the plant, turning the leaves red or blue. That is called servation, I think.
So we can see the path, right, that we take it up. So your conclusion is what?
The plant starts to turn red or blue whenever you put on the third day.
Thank you.
My name is Justin, and this is my project. Which liquid will rust the fastest? My materials are cornstarch, nails, orange juice, Coke, salt water, and water. My hypothesis was that Coke was going to rust the fastest because it had acids, but orange juice rusted faster than Coke because it had natural acids and Coke was man-made. And this project has to do with electrochemical, and electrochemical is chemicals that have to do with rusting and electric. How a shark uses electrochemical to find its prey. How a flamingo uses electrochemical to eat swims from one color to pink. And here are some charts that I have on day 2. For water, there was no rust. On day 2, for salt water, there was some rust. And for orange juice, on day 2, there was a large amount of rust. And on Coke, for day 2, there was a lot of rust.
So you did that, and you observed for how many days?
5.
5 days. So your data chart has all 5 days and what happened. Right. Okay, thank you very much.
Thank you, Joshua.
Hello, my name is Alex Lewis and I am in 4th grade. The title of my project is Does Light Travel in a Straight Line? My problem is I wonder if light travels in a straight line. My hypothesis is yes, I believe light travels in a straight line because the sun rays of the sun travels in a straight line. So why would all light travel the same? My materials were a ruler, clay, flashlight, 3 index cards, and scissors. And my steps to my project was first, I cut tiny holes in the cards, and then I rolled up the clay, I put it on the card, and I set it down, and I flashed the flashlight through it. So my conclusion is my hypothesis was right. Light does travel in a straight line.
Alex, show us how the light bounces off of the cards and makes the shadow.
Here's the circle, the triangle, and the square.
Thank you.
And my cup is how to protect soil. My materials are soil, wood, paper, 2 pieces of paper, eyedropper, and leaf. My hypothesis was that I thought the water would go through the leaf. My experiment is pulling a lid, water in a lid on the soil. Next, Preserve the cover with soil with leaves, apply water again. My observation was first that soil absorbed the water, paper stayed dry. Soil covered with leaves, the water rolled off and the paper got wet.
So Paige, what did we learn? What did we do with the leaves in our garden?
We put the leaves around our plants so the plants would not die from the ice, rain, ice, snow, and yeah.
So we found that by using the leaves, it was one way to be able to help the vegetables that we had already grown before we got the very, very cold temperatures last week, correct? Right, and then we found out that actually it did help when they were still alive, right? Okay, very good, thank you.
Good job, buddy.
My name is Luke, and my project is what heats faster, soil or water. My hypothesis was I think the soil will get hot faster than the water. My materials were a timer, 2 thermometers, potting soil, water, and 2 bowls. The procedure was gather all the materials, fill 1 bowl with water, fill the other bowl with soil. Every 15 minutes, check the temperature. My observation was the soil and water started the same. The soil heated up faster than the water every 15 minutes. My conclusion was my hypothesis was correct. Soil heats faster than water. Water is a slow conductor of heat and it needs to gain more energy than soil in order for its temperature to increase.
Hi, I'm Jaden Deere. I'm in 3rd grade. And my experiment will be, what does the solar system look like? My hypothesis was that the plants would be made of similar materials, but just different sizes. My materials were balloons, clay, paint, construction paper, tape, if this scale would have, if this scale had a sun, if this model had a sun, it would be 10 times the size of Jupiter, and it would be 14 feet tall, so it would be 6 inches taller than a sun. And the number 2 fact is Uranus has a cloud named Scooter. Scientists call it that.
Very good.
Is it color above ground or underground? My question is, it is winter and we want to know if it is cooler above ground or underground. My hypothesis is I think underground will be warmer than above ground because the air can't get underground to cool it off. My materials are 2 thermometers, cardboard, and a small shovel. My procedure is dig a hole in ground, place the monitor in hole, cover hole with cardboard, place other thermometer on top of the cardboard, and make the monitors after 30 minutes. My conclusions are it has been concluded that it is cooler underground because the sun does not penetrate through the ground and does not heat through the ground. Some people built their houses underground for several reasons. It maintains a nearly constant interior temperature due to the natural insulating properties of the surrounding earth. It also shields from the severe weather. The ground also absorbs sounds and keeps the house quiet from outside noises.
Good job.
My project is about pulses. My problem is how does activity affect a person's pulse rate? My hypothesis is I think that activity or exercise will make a person's pulse rate higher because heart beats faster when I run back. My procedure is take a person's pulse rate at rest and then record it on the chart. Have the person run in place for 1 minute. Take the pulse rate again and record it on the chart. Let the person run for 2 minutes. Take the pulse rate again and record it. The question is, did the person's pulse rate increase after running? Yes, the person's pulse rate increased after running for each person. And did the pulse rate go down after running? After resting, after running? Yes, each person's number went down. 2 people are on medication, but it still went down. And how does exercise affect the person's pulse rate? It makes the person's heart rate go higher.
Okay, very good. Thank you.
He was telling my science project is body evaporation. We evaporate gas condition. We turn a liquid into a gas to go away slowly to disappear or vanish. The hypothesis is I think paper cup will disappear the fastest because the paper material make it disappear quickly. My materials are a pie tin, paper cup, a plastic water bottle, and measuring cup, funnel, and water. The procedure was fill measuring cup with 150 millimeters in 1 day. Pour 1 cup of water into the pie tin. Pour 1 cup of water into the water bottle. The next day, pour the water from the cup into the measuring cup. The cold water level, then pour water back into the cup. The same with water and hydrant and water bottle every day for a week. Measure the water of each until record the results.
And what were your conclusions?
The pie tin, was much faster than the bottle in the paper cup or water bottle. The paper cup was the second fastest, and the water bottle was the last. The wide opening of the pie tin helped the water evaporate quicker, and the small opening of the water bottle helped keep the water in.
Very good.
Thank you.
that all work together to help you breathe. The lungs are important to bring oxygen and other gases to your body in order for us to live. The diaphragm is a muscle that separates the chest cavity from the abdominal cavity by moving downwards and creates suction in the chest to draw in air and expand the lungs. The lung model I made is made out of a dish soap bottle and two different kinds of balloons, one smaller than the other. The bigger balloon on the bottom is the diaphragm, and then the smaller balloon on the top is the lung. My materials are a dish soap bottle, two balloons, one balloon that's smaller than the other, and scissors to cut the bottom of the bottle, a rubber band, and or tape. Step 1 of my model is to cut the bottom off the dish soap bottle. Step 2 is to cut off the top of the bigger balloon and tie a knot in the other side. Step 3 is to open the end of the bigger balloon and put it on the bottom of the bottle. Step 4 is to stick the small balloon inside, pull it around, and then put the rubber band on it to secure. And then you pull your bottom balloon and watch what happens to the balloon. It fills up with air. And then my original hypothesis was that when I pulled on the bottom balloon, it would make the top balloon suck in, but I was wrong. It did the opposite, and the top balloon filled up with air.
Alana, would you show it to second graders? Will you go up closer to them and let them see what it does?
Cool, huh?
Good job, Lauren.
Hi, my name is Jacob Clinton and my project is Poor Man's Flashlight. My hypotheses are 1. The foil side of the strip will need to touch the battery to make the bulb glow. 2. The bulb will glow with the battery in two different positions. 3. You will be able to use the two strips of tape foil to make a longer wire. 4. The battery has chemical energy that will make the bulb glow. And 5. The wire inside the bulb glows because it heats up. And my materials were a flashlight bulb, a AA battery, foil, masking tape, clothespins, and scissors. 10. I found 2 ways to use the 2 pieces of tape foil to make the bulb glow. A. You can make a longer wire with both pieces of tape foil, or B. With one piece of tape foil, wrap it around the bulb. Get the battery and the other piece of foil and connect them. Then get the first piece of tape foil and put it on top of the battery. Then take the other piece of tape foil and put it under the bulb. And that's the end of my presentation.
Good job.